our speaker, who is Harsh Dariwal. He's an AI specialist focused on Gen AI systems, RAG, and AI infra. He is also an AI lead at Let's AI Solutions, and he's a core member and one of the leads in AI team in Women in Tech India. He's also founded GenAIWallah, which is an AI education initiative. So even if you want to know more about AI, you can always, go and reach out to him, and he'll be very happy to help. He's also recognized as a two-time Smart India Hackathon winner, and he's an AI researcher and author with an IEEE publication. So a big round of applause for Harsh as well. And with that, Harsh, I would like to pass it on to you.
Sure. Yeah. I'm audible?
Yes, yes, you are audible.
Okay. So in today's session, we are going to basically cover RAG and do something hands-on around the same, that how can we actually build it. So not just practical information, but I have prepared something where you don't have to code and then you can also play around with it and free of cost. So how many of you understand RAG? Can you write a yes in the chat box? Do you understand RAG? Okay. Even before starting, like, can you guys drop into the comment box, like, if you are a college student, or if you are a working professional, or if you are a tech person or a non-tech person. So you can write like college tech or college non-tech or working professional tech or working professional non-tech. Which of the categories do you fall into? So that we can get an idea that what's your background. Okay, tech, 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 others. Okay, we have Kansha here, Divya here, Srita here, Priyanka here. Okay, okay, okay. So all of us here and from tech only, right? Okay, all right. Let's start with this. So many people understand RAG on a very high level, but let's go deep dive into the same, that what it is actually, why do we need it, and all the other informations. So the basic building blocks of RAG are embeddings, semantics, vector DBs, hallucinations, and then finally RAG. If we talk about embeddings, we say that embeddings are simply numerical representation of the words. Everybody knows that. But when somebody asks you what are embeddings, you should say that they are a n-dimensional vector representation of a word or a sentence. Okay. So when I say a dog word can be represented into this, and when I say n-dimensional, it means there can be n elements into this array. Are we clear to this part? And most people have this doubt that if embeddings is a numerical representation, then how are these numerical representation actually presenting the word and its true meaning? So when we see that embedding model maps any piece of text to a dense vector, which is like every dimension is signifying a particular characteristic. So when a dog is here, puppy is here, every one will get a embedding like this, same n dimensions. And then what we see is that when we find the similarity between these 2 points, so we see this array, right? This array also represent a point, right? Like consider if it was just this 0.231 and 0.714, then this actually represent a n dimension 2D point, right? You can look at it at like this, like xy is there. So when I calculate the distance between this dog coordinate and this puppy coordinate, you will find out that these 2 points are lying very close to each other. So when I say uh, embeddings, numerical representation in such a way that all the words which have similar meaning lie close to each other. in an n-dimensional plane. So when I see dog and puppy lie close to each other, dog and car are not related to each other. And what kind of similarity do we see in embeddings, if you ask me? Is it the like absolute difference between the 2 points? No, it's not. It's actually the cosine theta. If you have read about vectors in your 11th, 12th class, you must, or maybe in college, as most of you are from tech, so you must have seen that there is cosine of theta, which is a dot b upon ab, right? So this is the cosine similarity. So the major doubt that we comes to our mind is that how does a model learn meaning? How was this numerical representation able to represent the true meaning of this word? So when we see there are some models available like word to vec BERT, they are trained on billions of sentences. Same way as LLMs are trained, these are embedding models which are trained on whole internet or lot of sentences. So they don't have a mapping of the same. That okay, for if dog word comes, I need to put it embedding of 0.231, 0.112. They don't have a dictionary like that. That okay, if this word comes, I have to map it to this word, this embedding. It doesn't work like that. How they work is, so they are trained on basically billions of sentences. Instead, they learn the meaning by their appearance. Same way as the child, a kid learns that this word is used in these kind of situations. Exactly the same way embedding models have learned that okay, if this word is appearing here in this sentence in this context, then this will be its vector embedding. So for this one, no human labeling is needed. This is unsupervised learning. You don't have to put labels to this. You can just have some unlabeled text, run it to the model while training, and then the model will understand how does this word come or appear in a dialogue or a paragraph, and then it provides a vector embedding to the same. That is how it is able to produce a vector embedding that is able to capture the semantics or the actual meaning of the word. The sentence from training corpus, I walked my dog into the park today. So neighboring words like walk, park, leash, bark, fetch, and all. These are all the words that it found that okay, the word is coming around these words. So it got a constant context of the same. And then these words are having similar vector embeddings. She drove her car to the office. Then, based on the data that it read, it had car. So, similar to car, what other words appeared? Drove, engine, road, fuel, etc. So, when we see word to vec, it is predicting your neighbors. Like it is given a word, and we predict the words likely to appear around it. We see when we pick a word dog, we look at the window. It around the dog. If I see this in this n-dimensional graph, what are the words that are appearing close to it? So walked, my, in the. So these can be the predictions. So when we see about this, how does it work? So this is a two-layer network, which is input layer, which is one hot encoding, and then a hidden layer, which shows that probability around all the words, so that we are able to get the true meaning of a word using its embedding. Then we update and repeat. This is the training phase. Okay. Do we see these clusters? When we say 300 dimensions, it means like we understand 2D, 3D. So this is like 300D. We do this so that we can get a higher accuracy. Representing a situation or a point in 2 dimensions is accurate, but in 3 dimensions, it is more accurate. We are able to provide more characteristics. Remember, every dimension here represents a particular characteristic, and that number shows how much relevant it is to that characteristic. So increasing these dimensions means increasing the accuracy. So when we see at this, look at this, we can see this cluster, which is dog, kitten, bird, puppy, cat. So all of these words, after getting their embedding from the model, are lying close to each other and they are forming some clusters. Do we understand that? Till now, if everyone has any doubt, please ask, because this is very important. If you got it, then please type a yes. Okay, all good. Okay, okay, all right then. Once we get this, we'll move to hands-on of the same. Then we understand about semantics, which is the meaning context geometry. So when we say semantics, like when I search for password, so have you ever wondered that while doing the Google search or something, we see that exact keyword match does not always work. Like when you have searched for like uh, hotels near Marine Drive under 5,000, similar to that query. So the websites that you get as a top results do not exactly contain the same word. They might contain a word hotel, they might contain a Marine Drive, but if you search for some specific terms like jacuzzi or something, so the website exactly doesn't contain the same words, but it is still able to produce that result, right? How is it working, or how do we work in this modern world where exact keyword match is not working? Let's say you search for like banana, uh, you basically on Blinkit, you type some other word how which you call banana, and then you still get banana. How is it working? Just because they mean the similar, but they are not the exact match. So we have same meaning, different words. So remember the semantic things, the embedding that we made. So embedding, even if we call it with different words, if even if we call dog a puppy or anything, all of that has similar meanings. If we use that search instead of this exact keyword match, we get a higher accuracy, because when we see for cosine similarity, those words which you are getting a higher similarity ratio, then we are able to use the same. When we say different words, like how do I reset my password, what is the weather today, these sentences and all, different words, opposite words, like for the words which has similarity of exactly the same, that is one. And if we look at the exactly opposite, the similarity between those will be -1. So the range of this cosine similarity while retrieving can be -1 to 1. Okay. Context shifts, meaning like he went to the bank. Now bank can mean a financial organization or a reverse bank as well. So it will, the context will definitely change according to how the sentence is appearing. So vector arithmetic, if we see that a word king is there, man is there, woman is there. So this is basically a arithmetic calculation shown. If we remove king, a man from the king, what remains? I think royalty remains. That person is in power. And if we add a woman in this, we get a queen. So this is a classical example used into this today's GenAI world. That if we understand this, that if we remove the man from the king and add a woman embedding, then we get a queen embedding. Do we get that? Because this making sense. Please write a yes if you got it, and then if you have any doubts, please ask. There are two dimensions. One is gender, one is royalty. If we are plotting the embedding of king, king and man will be close to each other. Why? Because most of the data that we have trained on has, I mean, all the historical data has majority data where king, man, royalty are close. There are lesser queens than the kings in the history. So that will be close. When you see king in the royalty dimension, if you remove a man, then you get, and if you add a woman, you get a queen. Okay. Then these are vector databases. So all the embeddings that we have God, we have to store that into a database, like similar to our relational, non-relational databases. We need a databases for these vector embeddings as well, and we need to store that as well, right? And perform searches there. So these are vector databases. So they what they do, they ingest and index the data. They provide us functionality to search by the vector proximity, and then they provide the like top k most semantically relevant chunks. When we see what are these top k semantically similar chunks, these are the neighbors. So when I say top k, I mean top k equals 10, then I mean that the top 10 nearest neighbors. Okay, then this is the k nearest neighbor search. We see that okay, if this is the query, so we see these neighbors according to the like query, a user's query is there. I will also convert the user's query into an embedding. Then I put it on the graph. Then I find out what are the nearest points to this query. Then I'll see that what are these sentences. And then while answering the user's query, I'll use this information available inside these nearby points to find out what exactly the user is asking about and what is the information do I have. Okay, we embed the query. The user posted that what is the refund deadline. It got converted into a vector embedding. Then I do ANN search via, you don't have to understand HNS blue and all, they can come later, but it's more like clustering only. And ANN is approximate nearest neighbor. So then we get the top k text chunks, which is like what are the top 10 or top 5 neighbors of the same. We pass this value of top k. And then we pass these chunks value to the LLM context so that we can understand what is the information, what is the our organization's documents. So when we see what are these documents that are present into this vector database, now we come to the main problem that why do we need RAG? What was the main issue that we needed this RAG? So all of us know about hallucinations, right? LLMs, on the previous session we covered that LLMs are trained on huge amount of data, but that data is like world's data. It is not customized or specific to any particular organization. Then if we ask the LLM about who won the see about this query, who won the 2025 World Cup? So what if the LLM was trained like LLMs, all of them have a cap date, right? If LLM was trained until 2024 December, it cannot answer that the learning has stopped at that point. So if the learning has stopped, the LLM will not be able to answer the queries which are asked after that. Even the Claude Sonnet and everything we use, they have a cutoff date of 2025 only. But then, if the LLM has the information of 2025, how can we make them answer information of today's date? Or maybe the news that was latest, maybe yesterday's. So how can the LLM answer that? This is a problem, right? Knowledge cutoff is there. We say, what's our Q3 refund policy? Now, a LLM doesn't know that what is romantics, sessions information or something. It doesn't have access to your private data because it was trained on general data, on the world's data. So how it will respond without any such infrastructure will be that typically Q3 refunds are processed within 30 days. So this is the general information that it has learned during the training, right? This is a problem. It doesn't have access to the data. Then we have confabulation, like cite papers on rank performance. So it puts up some information, these links which it has learned, but it is most likely hallucinating it. These links don't actually exist. So the links that you are getting here might be fake. You might have seen it many times as well. But the model is actually learning the pattern. It is learning how generally things work. When I say, let's say RAG benchmarks, it might create a link like XIV 2403 and then RAG underscore benchmarks underscore something, which it learned. But it doesn't necessarily mean that that link would exist. So these are some problems with LLMs, right? So while LLMs, they are learning pattern completion and not fact retrieval. So LLMs themselves are complete black box. So they have a cutoff date. They don't know our information, and they hallucinate about like events after cutoff. They hallucinate about a specific company's documents and internal policies, real-time data, and your product information. Then how do we make them able to get this latest information? The answer is RAG. Because of all these problems, RAG was introduced. So when we see RAGs, what we do, there is a indexing, which is a one-time offline job. You get all the documents. Suppose you want to create a chatbot for your organization. It has, let's say it's a HR chatbot. It has all the company's policies, leave policies, and like information like if you are planning to take a planned leave, you have to inform 7 days prior. Informations like these, which are specific to a company. We pass the documents into a chunker, which is basically dividing the whole page into sentences or paragraphs, right? And then this information is sent to the embedding model, which is taking those text chunks and converting into vectors, which are our vector embeddings that we just saw. And then for storing it, we are using a vector database, which is already indexed. Does knowledge cutoff still exist? Because LLM these days can search. So Divya, yes, knowledge cutoff exists for all the LLMs, even the LLMs you are using right now, and it always will. It will always exist. But there are workarounds available. Like if you can pass the information of external tools into the input prompt. So how do we work around with the same is LLM doesn't know about today's weather because LLM was trained and it had a cutoff date of 2025. Claude others and had 2025 only. But how it works is it basically has a tool. So it wants to know like what is today's date. So let's say there is a tool which provides LLM a date of today, and then it calls a API, which is an external that we will do later. So it's an agent with a tool. So agent itself is just the brain. It doesn't know what day today is. It doesn't know what is the weather today. It is taking help of external resources and then answering the question. So if it gets all the raw information it needs to answer the question, which is beyond its cutoff knowledge, then we have to basically pass this information into the input prompt itself. And the same thing we're doing with RAG here. Same thing we're doing with tools. We get the information ourselves, or basically we have implemented systems to get that information through some different means, provide that information into the input prompt so that the LLM can return the information in the response. Got it, Divya? Okay. And the phase two, once we have this vector database ready, then we get the user's query, which is what's the policy. What we do, again, we embed the query. We are using the same embedding model as this one. We are embedding the query using the same model. Then again, now see, if we retrieve the top k chunks, which means I said top k equals 10, then I'm basically asking for what are the top 10 nearest neighbor to this query. Just because this query was about what's the policy, it will lie around the same sentences of the documents which had words like policy. Do we get that? That this user's query which had what's the policy, so it will definitely fall around other chunks, other embeddings which had the word policies or documents or rules or something like that. It will fall around the same. So if I get all those top 10 sentences which contained or were semantically close to the user's queries, if I have those top 10 rules and regulations, and then if I put those sentences inside the input prompt, and then if I ask the LLM about it, then my LLM will be able to answer the query much more properly. Or maybe, I mean, it's the only way LLM will be able to answer user's query. So what will be my input prompt? The user posted this. what's the policy. But how we modified it will be that you are a useful assistant for HR chatbot. The user is asking what is the policy, and these are the top 10 documents or rules information that we have about our company. And then those 10 rules and regulations. Then LLM is getting this, but user is posting only this, right? So now the input prompt already has all the information needed to answer the question. Even if LLM had a cutoff date, even if LLM knows just pattern and the general information, but the input prompt itself contains all the information it needs to provide a response to the user. Then the LLM gets LLM plus context, which is a grounded prompt, and the answer we get is an accurate answer, right? What is the deadline to claim a refund on the damaged product? We embedded the query. We get the top three most similar policy chunks. Then we retrieve all the text chunks like these, which were present into the document. Customer may claim refunds for damaged goods within 30 days. LLM is getting this user's query plus this retrieved chunks, which is serving as a ground truth. Without track, we were getting answers like typically companies accept damage claims within 7 to 14 days. So this is a general answer. This is the pattern which the LLM learned during the training. But if I am representing a certain company like delivery or something, I want to provide the exact policy of my company. Then I use this RAG. It got the response from my documents, and now it says that okay, you have 30 days after the date of receipt. So we overcome this problem, right? Now we'll move to hands-on, but before that, if you have any questions, then please feel free to ask. I mean, most of our audience is technical here, but I have prepared a non-tech demo so that it's a like drag and drop thing, so you can easily work on it. You don't have to set up anything on your laptop. Okay. Any doubts? I'm waiting for 60 more seconds. If anybody has any doubts, any confusions, then please ask. So are we all ready to go to hands-on? Okay. So now to start with the hands-on, we understood that, let's think about it. We understood that we have to do RAG to like avoid these problems of LLM like hallucination, cutoff date, and not knowing about our personal information or private data. It doesn't know that. Okay, we know that information. So to do that, first we have to identify the use case. If the use case is building something around that I want the LLM to have access to my private data, or I want to make it personalized according to my data, my information, then I have to use RAG. We identified the use case. If it has problems like these, then we have to use RAG. Now to build RAG, what we have to do? We have to create a vector database. Now there are different vector database. Now I'm posting here a link which is playground.genaiwallah.com. If you go there, you'll be able to see a hands-on of the same. Okay. If everybody is on the same link, let me know. Are we able to open the same? Put a yes if you are able to open the same. Okay. You're here. Okay. So on this screen, so this is a no-code builder from GenAIWallah side only. That okay, here you can build flows. So it already has embedding models and LLMs running, which are open source. It is running on the same machine, so you don't need any other subscription with to basically work in the same. So now we go to this knowledge section. If you go to this knowledge section, you can say add knowledge. So what do we see here? We see this right here, what you see is a vector database. You put a name like WIT session. Okay. This is an embedding model here. So this embedding model is like noming embed text. This is running locally. So you can use it of free of cost. If you want to add some more embedding models in the thing, you can go to this manage model providers and then add some more like OpenAI, Anthropic or some others. But this is free, so we can use it. Now we see the content, ingest content. So DB provider is the one, like this one is already set up, Chroma DB, which is a local. It doesn't require any other setup. There are other options for vector databases, like OpenSearch is there, AstaDB is there, MongoDB Atlas, pgvector, and all of them. Now we see this section, right? Ingest content. Now what is happening in the ingest content? You are putting some files here. I'm choosing anything here. Mm, okay, just put in an assignment. Okay, we have chosen a file which is a PDF file. Now we will be doing is we will be converting this PDF file into some text chunks. Now we see some chunking strategies here. So it basically has chunk size, like how many characters or tokens do we want inside. You can go to this, the maximum length of each chunk accessed by the separator. So length of each chunk, we see chunk overlap. What is chunk overlap? Suppose you are dividing it using sentences. If you want the next 2 3 words of the next sentences to maintain semantics, then you can say like, okay, 2 3 extra sentences. How we are separating it? This is backslash n. So this is a new line field. Do we get that? Like, are all of these settings of creating a vector index clear to us? Put as if these information is clear to you, that if you know that all the settings you're reading here are making sense to you. How we are creating a knowledge base? We are putting a file, we are selecting an embedding model, we are selecting our database provider, we are selecting our file, and the chunking strategies. What are metadata? These are custom fields, like you can tag it into the same, like you can say file name and then put like marketing.pdf was the file name, that all of this data came from this file. Now when I click on next step, I see a preview that okay, this was the actual content of the scene, name, file, and everything here. Then if I hit on create, now let's see what is happening. It is ingesting the scene. It means it what it did is it basically converted the whole document into chunks and then ingested, like inserted all of that into a vector database. It was a small file right now. That is why it was able to do the same. If I click on view chunks, right, I'm able to see that okay, I had 100 maximum characters and new line. So it divided into assignment instructions 20, and this one was 83 93 characters. So you can definitely see these chunks here are not the best. So what it means, we have to reingest the scene using more characters in the scene and then a better chunking strategy. But currently, this was just to show you that, okay, this is how we converted all of these chunks into embeddings and they are now into a vector database, right? Now, we are good to have performing a search in the scene. Okay, I can see some other vector knowledge base as well. Okay, somebody has made this assignment here. Okay, WIT is there. WIT is there. Great. So have we all prepared a knowledge base here? Are we good to?
Actually, I have a doubt regarding the chunk size
Okay.
and overlap.
Okay. So see, this was a whole PDF. It had different paragraphs. It had different sentences. But every chunk has to have some limit to how much text we are storing inside a chunk, right? If I say 200 characters is the maximum cap, I'm storing into a single chunk, right? So that is the chunk size. Okay. And then if we see chunk overlap, let's say I see if the dividing strategy was chunk, basically new lines. Every new line should come into a different chunk, right? Then what will I do is I can have some chunk overlap, like this was sentence one, this was sentence two, which tells about something. So I can have information like this was sentence one, and then this was sentence two, so that I know that I am keeping a overlap, a buffer between two sentences, so that I can have some extra semantics as well. Like we are having the sentence one as well, but we are keeping some part of the sentence two along with it, so that we have overlapping chunks. As the name says, overlapping. So we have some next and previous information as well. All right. Okay. Now we're good to close it. Click on this logo. You'll come back to the screen. What you will do here is you will click a new flow. Just a second. Okay. A new flow is here. Now we can either go with a template here so that we can do it fast and understand it better. Mm, Let me open an old one. You guys can, after the session, you guys can just work on creating one. Okay. I am opening this one. So there are a lot of templates available into this as well. Okay. All right. Let's see here. Now there are different components available into this. Like there is a chart input, which is like I will start the chart where the user will provide this input from the same. Input text is there. What is this document about? Now, what we have to do, as we just said, we have to go to the knowledge, right? And we will get this knowledge component from here. Okay? Here is this component. You will get this component. You will connect this chart message to this search query. Now, what is happening at this stage that we discussed, that the user's query is also getting converted into a vector embedding. And then here we have to select which of the knowledge base. So here, all the information will be here, but all information that we created. I think I created this WIT session, so I'm selecting that one. You also the settings, top K results, number of the top results to return from the knowledge base. Okay. Here 5 is selected, so we are getting the top 5 chunks while answering the question, right? Okay. Now, what is happening next? We have a parser here. Parser is doing nothing but getting all of this. You have to select stringify mode. That we are getting a JSON from here, which is the top 5 results. We're getting JSON here, and then we're converting that JSON into string information. Like basically everything we're getting the JSON, we have stringified it, nothing else, right? Now we have a prompt box which says like this is a template here. Now let's open it. What it is having, it is saying that okay, this is the context. Context is what we see. Context is connected here, which is the stringified version of the results, top 5 results that we got from the vector database. So you can also say that. Okay. I can also move this down. Okay, given the context above is there now, then it is fine. Given the context above, answer the question as best as possible. So this was the question. And what is the question? The question we have got it same from the chat message that the user had provided. That what is this document about, right? So here, what we are doing is we got a message from the user. We are querying it against a vector database. We are converting into a string and then creating a prompt itself. So see, use as I said, user is saying this prompt, but how it is going to the LLM, it is going like this. All the context and everything merged with it. And then what we see next is there is this language model, which is the LLM. So here Gemma 3 is there, which is LLM, right? Now, what do we do? Input, inside the input, this is going, the entire prompt. And system message, this is like how the LLM should like identify itself. So you can pass something here. In case you want to pass something here, how it will do? You will just get a prompt, prompt template here, put some prompt here, and then connect this prompt to this one. So this is how you can pass a system message as well, right? Language model is here, and then simply a chat output component I have added here. So I mean, this is a very simple workflow, but is this clear to us? Okay. If we want to build a RAG system, so instead of my user directly going to the large language model, how it is working is the user's query is first going into the knowledge base, which is a vectors database. Then what it is doing is it is getting the top 5 nearest neighbors, which are semantically close to each other. Then what it is doing, it is converting into strings and curating our own prompt, which is going to the large language model. Like if we understand this picture, the entire scene of LLM will be clear to us. So this is very important here. Do we have any doubts? You can react a thumbs up if you think it is clear to you. Okay. Can we connect RAG to a local LLM that runs without internet? Yes, you can convert. In fact, this LLM that you are seeing here is also running without internet. It's just is running inside my virtual machine. So this is running completely offline only. Its public website is open to you, but all the things happening inside the scene are running inside my virtual machine, and they're not going to any public large language model or something. That is why this is free. No, once you have downloaded and set up the model, then you don't require internet access. So I have downloaded these models, these embedding models, these large language models, then I don't require the internet anymore. And it turns for free. Okay. Now let's say if I want to run this flow, what I will do is either I can click on this play button here. So now whole of this chain will run. Okay. I'm doing this here. Let's say user is going there, prompt is creating here, and then this query is running. You see this, right? And now we have a flow built successfully and each of these. Now this button that you see right now, this will give you more insights at each step. That you basically had a chat message, you can click on this inspect output. This one provided what is this document about. It went to a knowledge base, then this must have returned some JSON list, right? You can click on this inspect output. You see that okay, after the vector database, you see that okay, these are the 5 chunks that were retrieved from the vector database. You can see all of that, right? But okay, these are the top 5 chunks that I got and the outputs. Now what happened is it was basically converted into a string. So here is what happened. It converted all of that into a string. Okay. What happened next? We went on creating our prompt. What happened next? We see that okay, we pasted all the context and we said that given the context above, answer the question as best as possible. And the user's query, what is this document about? Now this query ran through the model, and let's see what has our LLM responded. Like this is document for a file marketing.pdf which contained information related to understanding usage of formula, procedure, and everything, which is assignment. Learning module tha, focus on all of that. And this we are providing as this output message here to the user. Okay. And if we go to this playground, this whole chat will open. That now you see that the normal workflow that you actually see for different LLMs that are working, they are a wrapper over this specific chain or specific RAG infrastructure, right? It, uh, Here is a file uploaded, and then you post this query, and in the backend, if you ask anything from the LLM, all of this process is actually happening. I This was it from my side, but let us spend some time. If you have any questions about the same, you can please ask. Now, like till now, I think RAG should be very clear or how you build it, what are different components inside a RAG architecture. Have you understood the same? Yes or no? Okay, okay. With other people as well, Ranjana, Jayanti. Okay. I'll also go and check if you guys have created some flows or not. Okay. 8 minutes ago. I mean, even after the session as well, this was just for the RAG, but you can build any workflow in the same user LLMs for free inside this playground. So that is something which I will recommend you doing even after the session. All right. Anyway, if you are looking for any documentation, you can just, this was playground.genaiwallah.com. You can remove the playground and go to genaiwallah.com, and then you can see all the documents here, tutorials of everything. So you can review the same if in case you need anything. Okay, that was it from my side. If you have any questions, please ask. Then Tanya, please take over. Akansha, yes.
Here, actually, we for the RAG we used a template, but how do we decide upon the architecture, like from where to go where? That I'm a bit confused about.
From where to go where, as in, can you elaborate more?
Like how do we build the RAG architecture? Like we used a already predefined template, so it was easier for us there. So like if we want to build a RAG agent of our own, like how do we decide on that architecture? Like what factors play a role in there?
It is exactly the same thing. Whatever we did right here, na, exactly the same thing. Like even this lang flow here, what you are using here, in the background, it is creating the code only. It is not a mimic of the same. So, see, mm, okay, let's go here. Okay, I'm not sure if I can share you the code here. This was export, and then it's a Langflow. This is a JSON file which you can easily import into the Langflow infrastructure and then use it. How it is working is, I assume you are a Python developer only, right? We simply take the chat input, that okay, a simple string which had the same. Then how it is working is we are querying the same inside the vector database. That is a simple, uh, simple function that you use. Chroma DB retrieve top K chunks. You simply import the same and exactly the same logic. Like, see, you imported langchain.text splitters, uh, import recursive character text splitter. You have a chunk size, chunk overlap, which we used while splitting the document, right? Everything here gives you an idea of how this entire chain is working. And you have to exactly use the functions. Now, once we have like, there are different text splitters in the same, chunking code is there. A small example is provided here, and then a retrieval is must be here somewhere. Okay. You simply retrieve it from the same. That okay. You're basically importing Chroma DB. You are initializing a client here, and then you say create collection is there, and you're inserting your documents. And then simply same way, what you're doing is customer support collection dot query. You're sending the query text, which is the user's query, top results that you want, and then you get this context here. You're converting this context into a string. What is this prompt template here? This prompt template is nothing but a f string. You can put all the values into that f string, and then simply by initializing the OpenAI client, you can put a query to OpenAI or any LLM provider of the same, and then you will get the response. I mean, this is a very high level, not a high level, like very direct explanation of how the RAG is working. All of these components, if you code it, these are like 3-4 lines of code. If you want actual code of the same, we can also provide you the same. But this is a lang flow UI, okay? So how it is working, it is working on the lang chain only. Like everything, every component here is representing some LangChain code only. See, you can click this code, right? This is the entire code of the same. This is much larger, much complex, just because it is a part of a huge library. But if you go and code it yourself, it will be 3-4 lines code, nothing more than that. Is it clear, Kancha?
Yep, it is.
Yeah. Okay. Anyone else?